Good day everyone. Today I will present the numerical differentiation project. We are from group 4. So this is my group member. First is Jackie AE23005X, and me Betty Cheng AE2300553, and the last is the Chipotle AE2300073. This is our table of the content about this project. First is the introduction, so I will explain what is the differentiations and who will use it in the real life. So first, differentiation is defined as a rate of change of a quantity. So in the most of real life applications, it will use in the physics or the engineer. So it used to measure how the variable change with the respect to another. For example, acceleration is obtained from the rate of change of velocity with respect to the time, where the mathematical practice this corresponds to find the gradient of a curve y equal to fx again x at a specific point, or to put it simple. So the slope of the tangent is the line to the curve at that point. Besides, there were times when the function is not easy differentiation analytical, or this is only discrete data available. So to overcome this situation, numerical differentiation is employed. By using these methods, approximate derivative using no data point. So the first derivative can be estimated using 2-point forward, 2-point backward, 3-point or 5-point center formula. So the second derivative also can be estimated using the high point method of 3-point or 5-point center formulas. In the methodology, we do the first derivative method and the second derivative method. By using the manual calculations from the formula, we put the relevant data inside the formula, and then we can get all the different in the manual calculation. For the simulation part, we tabulate all the data in the mapper and use all the data to find the different value. After using the mapper to solve the first derivation equation, then we can substitute the value of t equal to 3 into the equation, and we can do the absolute error. So in the second derivative part also same, we also put the relevant data inside to the formula to find the 3-point center difference and the 5-point difference. So by using the simulation part also same, we tabulate all the data into the mapper and find all the value. So
This is the question that I managed to find for our topic numerical differentiation, and by the function of the velocity of a rocket, we'll fill out a table with their respective values and with the appropriate step size. Next, for these values, we need to find the approximate acceleration value of v'4 and v'4 with all the appropriate difference formula. And after checking with the exact value, and we need to comment on which method gives the better approximation. Next, this is the manual calculation solution for our question. First of all, we need to find the exact value for the first derivative, and then by using the given t value and also with the appropriate step size of h equal to 2, we find the 2-point forward and 2-point backward difference value, and they also their respective absolute error value. Next, for 3-point central difference, 3-point forward difference, 3-point backward difference, and also 5-point difference, the same method will also used, and also we need to find the respective absolute error also. Next, for the second differentiation method, we use the exact value of the second derivative, and then similar to the first one, we also find the 3-point central difference and also 5-point difference value and also their respective absolute error. Next, we compare the absolute error value for these two methods. Since higher order formula gives smaller absolute error, therefore higher order formula gives better approximation.
for the simulation part, we got first differentiation method and second differentiation method. So we talk about the first differentiation method first. So the equation gives the equation, then we use the equation to do the differentiation first. After that, we divide the table value in the mapper. After that, we can see that the value is suitable for the 2 point, 3 point, and 5 point. So we just use the general formula from our syllabus, and then we insert all the value into our formula. So we can know that the 2 point forward value is equal to 22.6353, and the error is around 0.5204. And then the 2 point backward is around 221.6162. The error is around 0.49x6. So for the 3 point central, the value is equal to 22.1257, and the absolute error is equal to 0.0109, and the 3 point forward is equal to 22.0916, and the error is equal to 0.02327. So the 3 point backward, the value is equal to 22.0947, and the absolute error is 0.02019, and the 5 point value is equal to 22.114x, and the error is equal to 6.12 times 10 power negative 6. So for the second differentiation method, we used just now first differentiation method and ask the mapper to do the differentiation. So we use this formula to insert the data that we tabulated just now. So we can see that the formulas that suitable use is all. So we can start into the 3 point central formula, which is the value is equal to 0.5096, and the error is around 0.000269, and the 5 point value is equal to 0.5093, and the error can be approximate to the 0. So for the discussion part, in the project, we use two methods to find the approximated value, which are the first derivative method and the second derivative method. So by using first derivative method and second derivative method, the result for the manual and the software simulation are same.
In conclusion, the higher point differential we do, the result becomes more accurate because the small value of the absolute error. In this project, we can observe that from first derivative method, the absolute error of 5 point difference is at approximate 0, and the second derivation method, the absolute error at 5 point differential also approximate equal to 0.
These are the sources that we have referred to find the question of our topic, and also the books that we referred for our numerical differentiation solution. That's all from us. Thank you for watching.